Welcome back. In this video, I'm going to cover statistically significant. Is this outcome likely, unlikely? So we're going to start on the bottom of page 4, looking at question number 6. So they have this simulation set up, and they're asking if this coin is a fair coin or not. So what they have is they flipped the coin 20 times, calculated the proportion of heads, and repeated this process a total of 40 times. So essentially that tells you there's 40 dots in this simulated sampling distribution here. And we know the mean and the standard deviation are this and this. And they want to know, is this a fair coin? So if it's a fair coin, it should come up about 50% of the time heads. So what we could do is we could do a confidence interval. I'm going to give you two options here. So if we, on the left, do a confidence interval, we're going to be looking at 0.379 plus or minus 2 times that standard deviation, which turns into 0.197, 0.561, 0.197 to 0.561. So we can see that 0.5 is captured in this confidence interval. 0.5 is part of this confidence interval. So that means it's a reasonable or it's a likely or a usual value to get. So we would conclude it's a fair coin because 0.5 falls within this confidence interval. So the conclusion here would be the coin is fair because 0.5 falls within the confidence interval of 0.197 to 0.561. 0.5 falls within those values. Or your other option is if you want to start looking at this as, okay, what's the likelihood that we get a value of 0.5 or higher? So we're talking about, in this case, all of these points here or above. So all of those dots. So if we start thinking about counting those up, we got 1, 2, 3, 4, 5, 6, 7. Let me double check. 7. So we'd be looking at 7 out of 40, which is 2.5, 17.5, 17.5%, or 0.175, just converted to a percentage. So we're going to use the 5% rule here. That number is greater than 5%, so the results are not unusual. They're likely, they're reasonable. So you can see here, this is a fair coin because 0.5, or in this case larger, occurs more than 5% of the time. So let's just recap that. It's going to be a fair coin because a value of 0.5 or larger occurs more than 5% of the time. Okay, in this case, it occurs 17.5% of the time. So you don't need to do both of these. You can either do this with the confidence interval or the 5% rule. Either one. Next, we're going to move on to question number 8. So this is going to be a similar concept. So we have a simulation of samples. Each one had a sample size of 100, and they ran 500 simulations. So this 500, there's 500 dots here. Is there enough evidence from the simulated sampling distribution to conclude a sample of 0.4 is statistically significant? So here is 0.4 here. So again, we can tackle this in one of two ways. We could do the confidence interval. So if we go about that route, the confidence interval would be your mean, 0.301, plus or minus 2 times your standard deviation, 0.047. And I'm just getting those from over here, the mean and standard deviation, which will give us values of, let's see, 207,395, 207,395, 0.207 to 0.395. Okay, 0.4 is not in the confidence interval, so that means 0.4 is statistically significant. So 0.4 is statistically significant because it does not fall in the confidence interval of 0.207 to 0.395. And it doesn't matter that it's just barely outside the confidence interval. It's either in the confidence interval or it's not. In this case, it's not. If we were to tackle the 5% rule, so now we're looking at all the values of 0.4 or higher. So if I again take the highlighter tool here, we're looking at these dots, and we got a couple dots here. So we're looking at 1, 2, 3, 4, 5, 6 dots total out of the 500 simulations. So 6 out of 500 is 1.2%. Let me double check my math on that. Yep, 1.2%. So the value of 0.4 is statistically significant because a value of 0.4 or higher only occurs less than 5%. Oops, 5% of the time. So again, you have a choice. You can do the confidence interval, or you can do the 5% rule. So either the confidence interval or the 5% rule. You do not need to do both. Let's look at one last example and then give you a chance to tackle some on your own. All right, question number 10. Oops, there we go. So Elizabeth waited 6 minutes at the drive-thru, and she's upset about having to wait that long. She notified the manager, and the manager said, your result was very unusual. So they did a study. They found it's approximately normal. The mean wait time was 226 seconds. Standard deviation was 38 seconds. Now they're asking us to use a 95% level of confidence. We want to know, was her wait time unusual? So since they're specifying that, we're going to have to use a confidence interval. So for our confidence interval here, it's going to be the mean, 226, plus or minus 2 times that standard deviation, which results in 150 to 302, 150 to 302. Now, this is in minutes. We need to do a quick conversion here. So if we take that 6 minutes and we multiply that by 60 seconds per minute, this is going to equal 360 seconds. So we're comparing that 360 to the confidence interval. So we are going to say that her wait time of 360 seconds is unusual because 360 is not in the confidence interval of 150 to 302. And I think that's pretty much what I said. Yep. It falls above 302 seconds. So it is an unusual wait time. Okay, at this point, what I'm going to ask that you do is you are going to work on questions number 7, 9, 11, and 12. When you're done with those, come back and watch me go through those, hopefully answer any questions that you have. So you can pause the video now. Okay, looking at these 4 questions. Question 7. So they're flipping a coin 100 times, and they're repeating the process 40 times. So there's 40 dots in this graph here, and they want to know, do we think that the coin was fair? The mean and standard deviation are these. So you could calculate a confidence interval, 0.315 to 0.495. It's not a fair coin because 0.5 does not fall within that confidence interval. Or you could do a comparison using the 5% rule. So 0.5 or higher only occurs once. So 1 out of 40 is 2.5%. So the coin does not appear to be fair because 0.5 or higher occurs less than 5% of the time. Going ahead to question number 9. There's a lot of reading here. And there's a couple things that you do need to consider here. They want to be 95% confident of the results. So they have a mean, they have a standard deviation. We're going to use those to calculate a confidence interval. That's what you'll notice that I did here. The mean plus or minus 2 times the standard deviation results in a confidence interval of 0.123 to 0.371. Now, does the sample proportion obtained 9 out of 50 fall within that margin of error? 9 out of 50 is 0.18. So yes, that 0.18 falls within the 95% confidence interval. So this would be a reasonable result, a likely result, not anything unusual. Moving ahead to question 11. Again, with the 95% confident, determine an interval containing plausible, just meaning reasonable or likely values. So the mean plus or minus 2 times the standard deviation. They ask you to round to the nearest hundredth. So that's where I'm getting the 0.35 to 0.66 from. That's it for that part there. And then now they go on to say they selected 40 customers at random, and the proportion who prefer the new procedure is 32.5%, so 0.325, and the dealership decides not to implement the program. And we're tasked with explaining why. Well, this decision is reasonable because the proportion of the sample, that 0.325, does not fall in this confidence interval. And they devised the simulation based on the minimal requirement that 50% of the customers prefer the new procedure. Well, this does not fall within this confidence interval that was centered around 50%. So it's not reasonable to move forward with this new check-in procedure. Okay, we're going to tackle a couple of multiple choice questions in the next section of lesson and give you an opportunity to practice some more.